Suppose you have a 600 meters of fencing to build two adjacent rectangular corrals. The two corrals share corrals, share a common fence on one side. Find the dimensions x and y so the total enclosed area is as large as possible. And you need to copy this from the book. So in the book you can see that this is y, this is x, x, and x. So when I'm looking at this, I'm talking about two things: area and then the meters of fencing. So the meters of fencing is all of those parts that I have here. So if you look at all of my parts for my fencing, it's talking about every single side added up. So you can see I have 3 x's plus 2 y's is equal to 600. And then now my area would be x times y. So it's saying that the area has to be as large as possible. So this means I'm going to find my vertex to this. So the only problem I have is that this is in terms of x and y. So I need to solve for one of the variables here. So I'm going to go ahead and solve for y here, which I would pause the video and solve that. And you're going to get 300 minus 3 halves x. Now I'm going to use this, and I'm going to plug this into my y right here. So I have my area is equal to x times 300 minus 3 halves x. And I'm going to distribute the x, rewrite this, so I have negative 3 halves x squared plus 300x. And I'm going to find the vertex of this. So go ahead and pause the video and find the vertex. Also, when you're finding the vertex of this, only find what the x part is equal to. So that means that negative b over 2a is going to be negative 300 over 2 times negative 3 halves, which ends up being 100. So this is saying the max value for x is 100, but it's not asking me to find anything about the area. It's wanting me to find the dimensions. So I have to find x and y. So I know x is equal to 100 meters, and if I plug that back into here, then I'll be able to find that y is equal to 150 meters, and this would be my answer.